Okay, so let's get right into this.
Yeah.
I want you to just, for a second, think about a moment when you're completely relaxed. You're reading a book, maybe enjoying a quiet coffee, and then it happens. Out of nowhere, you hear a sound. And rationally, it's no threat at all. It could be like the click of a pen from across the room or that weird little clatter a coffee maker does sometimes, or even just a certain kind of metallic scrape, and boom, suddenly it feels like this jolt of pure electricity just runs right through your chest. Your shoulders tense up, you might even hold your breath, and your heart just starts pounding. All of that happens before you've even really registered what you just heard.
And that phenomenon right there, that sudden physical feeling of anxiety from something totally harmless, that is the absolute core of the material you sent over for this deep dive. We're looking at what the sources call the struggle of the brain and anxiety, specifically why our internal alarm system sometimes flags a simple noise as, imminent danger.
Right. So our mission today is to basically give you this shortcut. We want to get straight to why your brain makes that terrifying equation. Simple noise equals sudden danger. Because the key insight here, and honestly the part that surprised me the most in the research, is that this whole reaction is physiological first. Your body is already reacting before your mind even has a chance to, put a label on the sound. Logic is just way too slow.
Very too slow. We're exploring what scientists call trigger sounds. These are specific acoustic inputs that they almost seem designed to exploit a kind of biological shortcut in our brains. They completely bypass the high-level thoughtful processing centers, and instead they travel directly to the ancient primitive defense centers. It's like the brain is initiating a high-speed security override, prioritizing your immediate physical safety over everything else. And that override is exactly why you feel that panic instantly, even when, rationally, there's absolute no threat.
Which brings up this paradox that we have to sort of wrestle with, right? If we're these highly evolved creatures with these big, complex frontal lobes, why does our system treat the sound of, I don't know, a plastic keyboard key or the sound of fabric rubbing together, sounds we hear all day, as if it were a lion in the grass?
Yeah.
We use that phrase, it gets on my nerves, but the sources suggest it's a lot more literal than we think.
It is entirely physical. And what's really fascinating is that the sources isolate these very specific categories of sound. And they're almost universally reported as triggers, even across different cultures. We're not talking about sirens or obvious danger sounds. We're talking about the subtle, sharp ones.
Exactly. The material brings up that specific, almost painful grating sound of metal scraping against metal, that high-pitched friction noise. Or, and this one is probably even more common, it's a sudden sharp clicking sound, a sound that has a very specific percussive quality that just jolts the entire system. Really, any sound that breaks the rhythm of the environment can do it, but yeah, those friction and clicking sounds seem to have a special power over our nervous systems.
And we really can't stress this enough. This is not just you being mentally irritated. The consequence of this is a full-blown physical alarm, and the sources are really clear on the symptom connections. When this trigger happens, people report immediate, undeniable physical feelings, like that sudden pressure or tightness in your chest, or that sharp, almost painful tension that just grips your shoulders and your neck. Your breath gets shallow. This is not just a state of mind. This is your physiology responding to a phantom danger.
Okay, so we have to follow the signal then. How does that tiny innocent sound, like a chair scraping on the floor, how does it jump the line and go straight to full-on physiological alarm? Where does the wiring in the brain, split off from normal sound processing?
Well, to understand the speed, you have to look at the brain's architecture. It's really clever. Normally, when you hear a sound, the input travels from your ear to the thalamus. Think of the thalamus as the main relay station. From there, the sound is sent to the auditory cortex for analysis. What is this sound? Is it loud? Is that a person's voice? That's the thoughtful, context-aware route.
And that takes time. I mean, we're talking milliseconds, but it's enough time for conscious thought to actually kick in.
Precisely. But scientists have mapped out this secondary, much older evolutionary path. It's a true express lane. And it's designed solely for potential threat signals. It's a direct, high-speed connection from that relay station, the thalamus, straight past the rational cortex, and directly into the brain's threat center. It's less like a public highway and more like an emergency line that only the fire department can use.
Let's focus on that hardware, the actual parts involved in that express lane, because this feels like the core of it all. If the thinking part of the brain is skipped, what's the structure that's actually pulling the alarm?
That would be the amygdala. It's often called the brain's fear center, which is a bit of an oversimplification. It's really more like the brain's dedicated high-speed pattern matching processor for survival. And it operates on a principle of, let's say, zero tolerance and maximum efficiency. It doesn't analyze context, it just asks one question. Does this signal match a pre-stored threat pattern?
Okay, so if the conscious route thalamus to cortex to amygdala takes, let's say, 24 milliseconds, how fast are we talking for this shortcut? Does that direct route really let the amygdala fire off before we even know what we heard?
Oh, it's significantly faster. We're talking about the amygdala firing within maybe 12 milliseconds of receiving that auditory input. And that difference, those precious 12 milliseconds, that is the gap. That's the space where your body starts the fight or flight sequence before your rational self can even register, oh, that was just my neighbor closing a window.
Wow.
This is exactly why we call it the immediate pre-rational response.
So the whole mechanism here is this instinctual override. The amygdala isn't waiting around for the brain to identify the sound as, a squeaky toy or a piece of scrap metal. It's making a completely non-rational, almost binary decision based only on the raw frequency of the sound, the raw data.
That's it, exactly. The amygdala is running on pure survival instinct, which is always designed to err on the side of caution. If it registers a specific acoustic signature, a certain tone, a jarring pitch, a specific frequency band, one that is flagged as being historically important for danger, either from your own life or even from an evolutionary standpoint, it instantly generates that danger
Gotcha.
signal and just dumps a cocktail of stress hormones straight into your system.
Wow. And that biological fast track explains the instantaneous physical symptoms perfectly. The heart is already racing, your breathing is already shallow, and only then does the thinking brain kind of catch up and go, wait, hold on, why am I panicking? Everything's fine. It's just an incredibly frustrating mismatch between your body and your mind.
It is the absolute hallmark of anxiety that's rooted in this kind of auditory trigger. But our source material also goes into a situation where this sensitivity isn't just an occasional thing. For some people, it's permanently dialed up to 11.
Yeah, let's go there. Let's move into that realm of heightened sensitivity, because most of us experience that temporary jump scare, but some people are dealing with a much more intense, often debilitating reaction to these everyday sounds. We're talking about misophonia.
Misophonia, which, literally translates to hatred of sound, is so much more clinical than just being annoyed by someone chewing loudly. For people with this condition, hearing certain common, often repetitive sounds, it could be sniffing, tapping, a specific mechanical hum. It causes this sharp, profound increase in distress, anger, and anxiety. It's not just getting on their nerves, it's an overwhelming emotional and physiological catastrophe, all from a benign trigger.
And the sources give a really clear synthesis of the two primary reasons why the brain might hardwire this kind of link, leading to that acute sensitivity. The first path seems more, more straightforward. It's based on conditioning.
That's the memory link. Pathway number 1 suggests that the sound is tied to a specific high-stress memory. So maybe that specific high-frequency click was present during a time of real threat or pain or some sustained psychological stress in your past. The amygdala, acting as that pattern matcher, doesn't store the whole story. It just stores the sound as a kind of a trauma placeholder.
So even if you've consciously dealt with the trauma, maybe even forgot the context entirely, the sound itself is now permanently flagged as a warning siren. It's a classic conditioned response, isn't it? The sound alone is enough to bring back the entire physiological feeling of that past danger.
Exactly. But the second pathway, the second one discussed in the material, is, I think, even more surprising because it completely divorces the trigger from personal memory or trauma.
Right. This is the part that got me. The material says that sometimes the specific frequency of the sound itself just disrupts the nervous equilibrium. Can you elaborate on that? How can a sound wave break the brain's balance without any prior bad experience?
This takes us a little deeper into neurobiology. It seems that certain sound wave patterns, especially ones that are sudden, sharp, or highly repetitive, like the staccato rhythm of a clicking pen, they may inherently overstimulate a specific part of the auditory cortex that processes those frequencies. For some individuals, this input is just so jarring to the nervous system's rested state that it physically breaks that neural balance. It causes immediate sharp tension and distress, completely independent of any learned fear. It's more like a sensory assault than a memory.
That's a huge distinction because it means the reaction isn't always something you can just, reason your way out of, by addressing past trauma, sometimes the physical sound wave is the actual antagonist.
And here's the crucial takeaway from both of those pathways. Even if the original memory or the context is completely forgotten, or maybe it never even existed in the first place, the negative feeling, the physical tension, it still arrives instantly and powerfully. The amygdala never forgets that initial association or that inherent disruption. It only knows one thing. This signal means alarm.
Okay, so if we accept that the conscious brain has lost the why, but the amygdala is still firing that threat signal every single time it hears that sound, what does knowing all this actually offer you, the listener, when you're struggling with these sudden bursts of anxiety?
I think it offers immense clarity. It reframes the anxiety completely. It means that feeling of sudden tension or fear from a harmless sound isn't evidence that you're failing to cope or that you're being irrational. It is the direct, demonstrable result of your brain's most ancient survival mechanism making a lightning-fast, precognitive decision. It's just a biological necessity to prioritize efficiency over logic. You're just experiencing the fallout from a very old, very fast defense protocol.
And that knowledge itself, it becomes a tool, doesn't it? A tool for de-escalation. The moment you feel that intense bother from an innocuous click or a high-pitched sound,
Yeah.
you can actually stop, take a breath, and understand, okay, this is just my amygdala, my internal security processor. It's activating a threat protocol based on a frequency match, not based on any actual real danger in this room right now.
Absolutely. The moment you can understand that the noise is just a stimulus and the tension you're feeling is an internal hardwired protocol that fired too fast, you gain distance. You can separate that intense emotional and physical reaction from the reality of the situation, which is that you are perfectly safe. And that cognitive separation is really the first step towards stabilizing your nervous system's response to these triggers.
That's the difference between feeling like you're being attacked by the world around you and realizing your own internal safety mechanism is maybe just a little overly sensitive or it's running on old, outdated code.
Exactly. And understanding the mechanism makes it feel less overwhelming. It's not some vague emotional problem. It's a neurological sequence we can actually map. And because we can map it, we can begin to mitigate its impact.
That is a really powerful distinction to take away from all this, which I think leaves us with this final provocative thought to chew on as we wrap up this deep dive. If that physical feeling of danger arrives instantly, your body reacting to a signal that might have been flagged years ago or maybe even generations ago through evolution, how many of our other seemingly irrational anxieties are just those neurological echoes, just waiting for the exact right frequency or cadence to play, reminding us of a danger that is long, long gone?
The brain is a master of efficiency, and sometimes that efficiency just means skipping the facts. We encourage you to keep exploring these fascinating and sometimes frustrating shortcuts our nervous systems take every single day.
That's all the time we have for this deep dive. We'll catch you on the next one.